Okay, in this session I'm going to tell you about indexing and hashing. First we will understand what is an index. An index is a access mechanism, okay, that helps me locate where a record is present. Okay, it gives me the location of a particular record, and on the basis of what does it give me the location? It gives me the location on the basis of a search key. So let's suppose I want to find out the record of an employee whose employee ID is equal to 743. So I would look into the index corresponding to the employee ID is equal to 743 entry, and I would find the address where this employee record is stored. It would be something like, let's suppose this is my index, and let's suppose this is my file. Okay, so I would have information in my file, right? And I would have one value where, or rather one record where employee ID is equal to 743, and over here I would have many values like, right? So this is my index, this is my file. So my index for 743 would point to this location. It's gonna directly give me the value where the employee whose record is having an employee ID 743 is stored. Okay, now let's look at the factors that determine the quality of an index. Factors for quality of an index. Okay, so first is the access type. Okay, access type would indicate, does it actually give me the access to the record that I want, or does it take me to a record which is nearer to the record that I want? Okay, there can be two cases where I need 743 and my index takes me to 743. Okay, and there can be another index where we have values like 736, 753, 724. Now in another type of index, it can be possible that I need 743 but it takes me to 724, and from there I have to go to 736 and 743, finally reaching my desired record. So that is about access type. Okay, next factor is access time. How much time does it take me to find my record with the help of index? Next is insertion time. Okay, whenever a new record is entered in the file, then how much time does it take for me to insert the details about this record in the index? Okay, how much extra time does entry in the index cost? That is about insertion time. Similarly, we would have a deletion time. Okay, whenever I delete a record from my file, I would have to delete the corresponding entry from the index as well. So the time incurred in this process is deletion time. The next is space overhead. How much space does the index itself take in the memory? That is about space overhead. Okay. So let's see what are the types of index that we have. We have basically broadly two types of index. Okay. One is an ordered index and the other is a hash index. Okay. A hash index is the one which is created via a hash function, while an ordered index is the one which is created for a file in which the records are ordered in some particular way, and the index itself is ordered with respect to search key values. Okay. Here we use the hash function. Okay. Let's now first take ordered index. Okay. So let's suppose I have a file in which I have employee IDs like this. This file is organized with respect to the employee IDs. Okay. But just understand one thing here. It is very much possible that this organization is not physical but logical. Okay? A logical organization would have pointers. So 123 would point to next value, which is 234, and 234 would point to 432. 432 would again point to 432. Then 432 would next go to 456. 456 now would go to 653. 653 guy goes to 729, and finally 729 guy goes to 789, and 789, let's suppose, is the last entry, so it is null. Okay, so this is my ordered file over here, ordered or sequential file. Okay. A sequential file does not necessarily have to be physically sequenced. Okay. And suppose, so these were my employee IDs. Okay. Let's suppose we also have PAN numbers. Okay, I have PAN numbers. Okay, so this indicates my PAN number. So this is my file which is having two attributes. All the records are having two attributes, just for the sake of simplicity. So I would have an index. I would have an index which is going to have values like 234. Say, since this is an ordered index, the value in the index would be sorted. So first we have 123, then we would have 234, we would have 432. Okay, then we have, okay, we would have only one 432. What do we have next? We have 456. Then we have 653. And we have 729 and 789. Okay. And my index would store a pointer. Okay. So it's going to be something like 123 would point to this record, 234 would point to this record, 432 would have, let's suppose, two pointers. Okay, first pointer would point to this record and second pointer would point to this record. Then 456 would point to this, 653 would point to this, 729 pointing to this, and 789 pointing to this record. So this is my index that was based on employee ID. Okay, similarly I can have one more index which is based on, let's suppose, my PAN card. Okay, so here I would have values like 3106. What is next? 4321. What is next? Okay, it's not gonna be 4321. It is going to be 43. Okay, it is going to be 4321. No, it's going to be 4216. Then we're going to have 4321. Okay, then I'm going to have 7153, 7153, 7163, and 7273 and 7567. 7273 and 7567. Okay, let's suppose this is another index. Okay, and I say this is based on what? PAN numbers. And this also would point to 3106 would point to 3106, 4216 would point to this, 4321 would point to this, and we will just complete it. Okay, I won't show it. I would just show the partial pointers. Okay, let's assume it is pointing to appropriate record. So in such a case, I call the employee ID index as primary index. Why? Because an index which is created on the basis of attribute value, which is used to sequentially arrange the file, is known as a primary index. Primary index is an index which is based on an attribute value used to sequentially arrange the file. Okay. So this is my primary index. And my PAN number is a secondary index. Okay. An index which is not a primary index obviously is going to be a secondary index. The attribute for a secondary index is not used to sequentially arrange the records in the file. Right? So we have seen what is a primary index. One more thing, primary index is also called as a clustering index. Okay. Right. Now we will also look at some more terminologies. These terminologies are a dense index. Okay. A dense index has an entry for every possible search key value. Okay. So these two are dense indices because they have all the values which the file has. Okay. A sparse index on the other hand has only entries for few of the values of the search key. Okay. So let's suppose that in this index I don't have these two values. Okay. So this index would become a sparse index. Now in order to find 729, I would find the record which is just smaller than 729. So I would go to the record containing the 456 search value. From 456 I would go to this record and I would follow my pointers. So 456 is pointing to 653 and 653 is pointing to 729, and in this way I find my entry. Okay. So after finding a nearer record, I follow the chain and find my desired record. Okay. So you reach to a nearest record and then follow sequence or pointers. That is how you use a sparse index. Just understand one thing with respect to dense index, and that is it does not necessarily have to keep two pointers for a repeated value, right? Like we have 432 here, which is repeated twice in the file. So for an ordered dense index, it is not necessary that both the values be stored, because once I reach to the first value, then I can obviously follow the pointer and locate my second value. Okay. So that is one thing you should keep in mind regarding dense indices. Okay, just realize one other thing. Why at all do we have sparse indexes, or rather indices? The reason is a sparse index requires less space than a dense index. Okay. Despite the fact that dense indexes are very fast, they give me the direct location to the record that I need. I at times would use a sparse index because my dense index would become very heavy, in the sense it would require large amount of space in the memory, and if memory is something which is at a stake, then I would rather use sparse index. Okay. Next we will see multi-level indices. Okay. Multi-level indices are sparse indices. Okay. So let's see how they are used. Let's suppose I have a file which has 1 lakh entries. Okay, that is 10 raised to power 5 entries I have in my file. Okay, now if I create a dense index, then I would need to have these 10 raised to 5 entries in the index itself. So that would be a very large index. So I would create a, let's suppose, sparse index. But even if I create every fifth value in the sparse index, then also I would have 20,000 records in my sparse index. Okay, so let's suppose I can store 200 entries per block for an index. Okay, so I would still need to have 100 blocks in my main memory so that I can search a particular index record. Okay, 100 blocks. So, or rather, if we let's suppose we can do the binary search, then I would need to have block 200, which is around 7. So at least I have to make 7 block accesses to find a particular record. Okay. To overcome this problem, what we do is we just assume that sparse index itself is a file, and we create another sparse index on this sparse index. Okay, so this is a file. Okay, now let's suppose we had 100 blocks over here and we create an index for every 5th block. So I would have, say, 20 blocks over here. Okay, so I would create a series, or rather a level of sparse indices. This is my outer sparse index, this is my inner sparse index, and this is my file. So I have 20 blocks. If I do a binary search over here, it would take around 4 blocks to access my index entry. Okay, so in 4 blocks I would be able to reach here, and another block access I would be able to reach the appropriate entry. So in 5 block accesses, okay, in 5 block accesses I am able to reach the appropriate entry, right? Or actually this would be 5, right? So we will rather have, let's suppose we take 10 blocks, okay, over here. We want to save more space, okay, so every 10th block we store in the outer index. So I would have my value as log 2 of 10, which is around 4, right? And in 5 block accesses I would be able to find my particular record. So this is the concept of multi-level indices. So let's suppose I need to find a record whose search key is 21,634. Okay, so here I would have, let's suppose, a search key 20,000. Okay, so this search key would point to a block which would have search keys having, let's suppose, values between 20,000 to 30,000, say 21,000, 22,000, 23,000, 24,000, and so on. So in this I am going to, let's suppose I have a value 21,500. Okay, so from here this sparse index is going to take me to 21,500, and I would follow the pointers from here to reach 21,634. So that is how I use a multi-level index, which is a sparse index on another sparse index, where the inner sparse index is on a file and the outer sparse index is on the inner sparse index. We can have any number of levels here. Okay, so now let's see how do we make updations and deletions in an index. Okay, index insertion. Okay, first we will see how do we do for a dense index. Okay, dense index has an entry for every search key value. Okay, so if, let's suppose, there are two cases here. If entry is present in index, then I would see if I store pointers to all the values. Okay, if I have 432 3 times in my file, then if I store pointer to all the values, then I would update. Okay, if I store pointer to all records with same values. Okay, then I update the index with this value. Update the index with the pointer to this new record. Otherwise, I already have the pointer to the first record which has this value, and I do nothing else. Do nothing. Okay. So if entry is present in the index. Now let's suppose if entry is not present in the index. Okay, this is the outer else. I would just connect this like this, and this thing like this. Okay, if entry is not present and this is a dense index, then we are going to include a new entry and pointer to this new record. Right? And let's suppose if this index was sparse, so for a sparse index, we will just assume that for a sparse index, the index stores just one value per block, and that value is the least search key value. Okay, least search key value, valued record, only pointer to this record we are storing in a sparse index. Okay, so again there is a case if we are adding this new record in a new block. If adding in a new block, okay, then we simply add a new index record and insert this entry in the block. This entry in the new block. Okay, right? Otherwise, if we are adding in some old block, then we again have a case here. If there is already an entry over there, if there is an entry, or rather we won't take this because it is an old block, it is very obvious that there is going to be an index record for this block. So my case would be if this record search value is less than index records search value, then I would update the index record pointer to the new record. Okay, and we would also insert this record in its appropriate block. Else, if this new record search value is greater than the index entry, then we do nothing, just insert the record. Okay, we would insert the record here as well. Obviously, record has to be inserted anyway. We are currently concentrating on what we are going to do with the index entry. Okay, so that was about how to insert a new record. How does it affect an index? Okay, now we will take a look at how to delete a record. Deletion. First we will take a look at dense index. Okay, in a dense index, if the record which is being deleted was the only record with the particular search value, if record being deleted was the only record with that value, only record with that search value, then we delete the index entry. Okay, we delete the index entry and we also delete the record. I won't write it again because that is very obvious. Otherwise, else we update the pointer of the index entry to the next record with the same search value. Okay, so let's realize what is happening here. Let's suppose this is my index and this is my file. Okay, I have 25 here and I have in my file I have a 25 over here, I have a 25 over here, and if I am deleting this, okay, so obviously this is pointing to this. If I am deleting this, then I would have to update my pointer so that it now points to this, and this is deleted. We'll use some other color. This is deleted, right? We are deleting 25 so that pointer also has to be deleted and it has to be made to point to the next 25 search valued record. Okay, so that was about dense index deletion. Now we will take a look at the sparse index deletion. Again, we are assuming that we are storing least search valued record per block. Okay, so we have two cases. If record doesn't contain an index entry rather, then do nothing, just simply delete the record from the file, right? However, if it has an index entry, then replace the pointer so that it points to next higher search value in the block. Right? We will just see in a diagram what is happening. Let's suppose this is my block. Okay, it is block. This was file. So, and this is index. So let's suppose I have a record for 25 and 25 is my least valued search key in this block, and the next value is say 26. So if I have to delete 25, then obviously currently it is pointing to 25. If I have to delete 25, then I'm going to delete this and make this point to 26, right? So that was deletion. Okay, so we've covered deletion in sparse as well as dense index. Let's now take a look at secondary indices. We've already touched upon it in the introduction part. We'll just elaborate a bit further on this. Okay, so I'm assuming I have a table which has employee ID 1, 2, 3, 4, 5, 6. Okay, this is my table which is arranged with respect to the employee ID of the employees. Okay, and I have their ages, say 30, 25, 40, 27, 36, 52. And we have other attributes. Currently I don't much care about those. Okay, so I already told you when I create an index on the basis of an value which is used, or rather on the basis of attribute which is used to sequentially arrange the records, that index is called as primary index. Okay, so let's say this is employee ID. So if I create an index using employee ID, that would be a primary index. And if I create an index using age, then that would be a secondary index. Okay, because the age values are not arranged in any particular order. Okay, so if I have to find the person whose age is 40, what is the way out for me? If I don't have an index, I would have to take a look at each and every record. Therefore, if I have to make this operation quicker, I create a secondary index based on age, right? Just understand that a secondary index is always dense. Why is it dense? Because let's suppose I want to find out the person with age 36. Okay, I want to find out this guy, and in my index, let's suppose I have an entry to 27, or rather let's suppose I have an entry to 25. Okay, now I have reached here, but now where do I go? Since it is not necessary that 36 would be down below, it could be up above also, because we have not arranged these records with respect to age. Hence, even after finding a nearer value, it is very difficult to find the correct record. Therefore, we always create a dense secondary index. And other thing is, let's suppose I have another person whose age is 36. Okay, so even now, if I have a record, or rather an index record with 36 search value, which points to this guy, I won't be able to find this guy who is also 36, right? Because these are not arranged with respect to age. Therefore, a secondary index is having records for all values or all records, or I would rather say search records. It is having an entry for all records with same search key value. Okay, so for all the people having 36 as age, I should have a pointer. So this is it. Okay, so it is dense and it has all the records for a given search key value in its index entry. Okay, also most of the times it is multi-level, right? Because it's already dense, finding a particular record would be very difficult because we have large number of records. So we need to have multi-level so that we can quickly find a particular record. Okay, why do we create this? We create this because we are expecting queries on attributes, or rather on non-primary attributes. Okay, this is not primary key, this is primary with respect to the attribute which is used to arrange the files, arrange the records in the files. Okay, so when I'm expecting many queries like find the employees aged greater than 25, or find employees whose age is between 20 to 40. These kind of queries, if I am expecting, then I would create a secondary index, because otherwise I would have to search, or rather look at every record in the file to look for these 20 to 40 employees, the persons who are aged between 20 to 40. Otherwise, I would simply, if I have a secondary index, I would simply go through the index and only see the index records which are having 20 to, okay, this is 20 to 40. I would take a look at only these entries if I have a secondary index. Okay,